All right, so the recording got started. So let's dive into today's lecture. Okay. All right. So I'm going to open up my Jupyter notebook first. Okay. And we're going to get started from there. Here we are. So I'll go to the Python code, teaching folder, go to something called different kinds of cross-validation techniques. So I want to discuss something called, all different types of, or different kinds of cross-validation techniques we can apply. Okay. Remember in the last class, I'm sure you remember that, but let me just show you one. Now, the idea that we, sorry, let's have a look here. One of the things that we have seen, we have a raw data, or let's say we have a process data. Okay. All right. So what we have, all right, let's start from the beginning. Okay. We have a raw data, the data that you have collected, and what you do to the data, you pre-process this data, right, Nakina? You do different kinds of things on this data. You pre-process the data, and once you apply different pre-process techniques, different kinds of things could be there. You could be applying feature scaling, you could be doing other kinds of things, okay. So you may have to drop features, you may have to handle, null values if there are any, redundant values if there are any. Sorry, what's going on now? So you do the pre-processing. Okay, once you have done the pre-processing, now what we have is we have a data set, pre-processed data set, which is ready for machine learning algorithms to work on it, right? Okay. In the last class, what we have done is we take the pre-processed data set, okay, and we split it into two parts, right, Nakina? Yes, we split the data set into two parts. Remember that, Nakina?
Yes,
one
sir.
of the part was the train set or the train subset. Okay, train set or train subset, whatever you want to say. Let's call it the train set. And the other one is a test set, right, Nakina? We have seen that. Now, when we want to apply machine learning algorithms, of course, the idea was you have machine learning algorithms or classifiers or estimators, whatever you want to say. Same thing. We're talking about the same thing, machine learning algorithms, or maybe we're talking about a classifier. If it's a classification problem, right? If it's a regression problem, then it's a regressor, or sometimes we also call it the estimator, whatever it may be, okay? You apply that algorithm on where? Where do you apply this algorithm on? You apply the algorithm on the train set, right, Nakina? So you apply that algorithm on the training set. Clear, Nakina? Once
Yes,
you
sir.
apply the algorithm on the train set, what you produce is a model. You have a machine learning model now, okay? So you have an ML model, okay? Now you would like to, measure the performance of the model. Now, in order to measure the performance of the model, yeah, of course, you can again apply the train set on that one. That would give you some performance measure, but that's the training performance, okay? But it's also very important for us to see how well does it do on data that that the model did not see. And the test set is the set of, is a subset that the model did not see. So we could apply this one on this machine learning model, and this would give me some performance, or it will tell me how well does it perform. Okay, so it gives you something about the performance measures. So that's the whole idea, right, Nakina? That's something we have done in the last class, right? Yes or no?
স্যার মডেলটা ট্রেন করার পরে আমরা ওই ট্রেন সেট দিয়ে যদি আবার পারফরম্যান্স মেজার করি তাহলে এটা কি 100% মানে
No,
এটা
not always, not always 100%. ঠিক আছে, ওকে, রাইট? ট্রেন সেট দিয়ে করলে কি একদম একদম এক্স্যাক্টলি সেম হবে তা তো না, তাই না? আপনারা হয় না, আপনাদেরকে যদি 10টা কোশ্চেন দিয়ে দেই, পড়ে আসেন, আবার ওই 10টা কোশ্চেনের উপর যদি এক্সাম নেই, you may not get 100% out of that, তাই না? নাকি না? Yes? So it's the same thing. You may not get 100%. ঠিক আছে? Okay? You'll have training performance and test set apply a test set did apply. You'd see how does it perform on a test set. So you have training performance and testing performance. Okay? Maybe you're measuring accuracy, then you have training accuracy and test accuracy. And why are you asking this question? Because I think you remember in the last class, আমরা যখন decision tree apply করেছি, training accuracy এবং test accuracy graphic আঁকছিলাম না? Yes, মনে আছে? Yes, yeah. Among training accuracy, not necessarily was always 100%. So training set apply করে যে সবসময় 100% হবে, that's not true. ঠিক আছে? Is it clear নাকি না? Are we good? Yes. Acha. Now, here's today in the first half, what we want to talk about is something here. We want to talk about how did we actually divide this data set, okay? And we saw one way of dividing this data set. One way we do that is by dividing the data set into two parts. One is the train part and the test part. It turns out that there are other techniques that we have as well. Yes. So you divide into train part and test part, and then you create the model using the train part, and you evaluate using the test part. Of course, you also can evaluate using the train part as well. So you have both training accuracy and the test accuracy. Is that okay, Nakina? Clear? So if you're measuring with the test set, you'll have something like a test accuracy. I'm just saying accuracy in a loose way, but because if in future you're gonna see in the next week, the accuracy chara aro onek kichu measure kori amra. And if you're using the train set to actually evaluate the model, you get the train accuracy as well. Is that okay, Nakina? Clear? So you now know how does it do with the train set and how does it do with an unseen test set. Is that clear, Nakina? Yeah? So that's something what we have seen in the last class. Now, it turns out that there are other techniques that we can also use. Instead of just dividing into train and test set, we can use other techniques as well. So that's something what we're going to look at today. We're going to look at all different kinds of cross-validation techniques that we have, okay? So let's get started, okay? What I'm going to do now is I'm going to start with a particular data set, okay? And this data set has been actually downloaded from Kaggle. This is the cancer data set, okay? So if you want to go, right click, open link in the new tab. Now, this data set in the CSV file যেটা আছে সেটা আপনাদের Google Classroom upload করা আছে, so you can actually download it from there as well. So you see over here, we have a data set on, the Wisconsin's cancer data set. ঠিক আছে? So it detects cancers. Okay? It measures certain things. Like for example, this is ID of a customer, perhaps. The patient perhaps. Diagnosis is either M or B. M stands for is malignant, or B stands for is benign. So if it's malignant, it's serious, it's cancerous. Benign means is perhaps not cancerous. Okay. And there are other features you have. There's a lot of features actually. There are altogether 32 features, including the diagnosis. There's a lot of things: mean radius, texture mean, perimeter mean, and so on. So what we want to do is we would like to use these features to be able to predict what is the diagnosis of this particular patient. Does the patient have, malignant cancer, or does she have benign cancer? That's something we would like to predict. Is the motive clear, Rakina? Is the motive clear to all of us?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So if the motive is clear, I'm going to now let's discuss different kinds of things that we do. Okay. First of all, let's import the pandas. Okay. Actually, let's do one thing so that you can also, I will just restart and clear output. So there will be no outputs over here so that you can see what's happening. Okay. So the very first thing that we're going to do is we're going to import the pandas because we're going to read the data set. So pd.read CSV, and we store it in a data frame called df. And we are printing the shape so that we know how many rows and columns do we have. And also we are printing out the first 5 instances of this particular data set. So let's go ahead and do that. Once we see that there are how many instances?
569.
569. 569 instances. and there are 33 columns. We already know there are 33 columns. Okay, well, 33 columns here, but it says 32. Okay, so anyway, there are 33 columns actually. Okay, altogether there are, so it's এখানে originally the 32 আছে, এখানে আবার 33 আছে. Okay, there's something interesting going on here. So if you go here and if I go here, একটা weird একটা ইয়ে তৈরি হয়ে গেছে, কি বলে, কলাম তৈরি হয়ে গেছে আমার অরিজিনাল যে ডেটা সেটটা ছিল. If I go to the original data set that we have, so if you go to that particular folder, so if you go C uses Python code, teaching, this is the one we are looking at. So let's open up the cancer data set. So that's the data set that we have. মজার ব্যাপার হচ্ছে, আমি যদি দেখি এগুলো হচ্ছে ডিফারেন্ট প্যারামিটার্স. মজার ব্যাপার হচ্ছে I don't have that parameter, কিন্তু এখানে খুবই weirdly একটা extra column তৈরি হয়েছে. Did you see that? This extra column is called unnamed 32. But anyway, don't worry about that. এখানে সবকটা হচ্ছে nan, this means not a number, nothing is there. Okay, so we do not need this column. So this is something that has happened, so we want to get rid of that. We will get rid of it, don't worry. So in any case, so we have read the data set. Is this clear, Nakina? Yes? Is that okay?
Yes, sir.
Yes, sir.
So for each row, let's look at the first row. So we have a patient ID. We have the diagnosis. This is the one that we want to target. Diagnosis is the one that we want to target. And the other features we have are the radius, mean radius of that tumor, texture mean, and there are other things as well. So there's a lot of parameters there are. And there is an extra, some sort of unwanted column has been created. Okay, all right, we'll get rid of that unwanted column as well. Okay, so the first thing that we are going to do, we are going to drop NA. What is drop NA? Anybody?
স্যার নালগুলোতে নাল যে ইনস্ট্যান্স গুলো আছে সেগুলো ড্রপ করে
Yeah. So drop NA function of the data frame will drop if there is nothing, if there's a missing entry there. Okay, so this is one way we could handle the data set. I handle the missing entries if we have. Okay, so I'll show you. So if you go drop NA function bhitor, je kono function bhitor, if you place your cursor and press Shift Tab, it will give you all the parameters you could have. So let me just একটা আলাদা ট্যাবে ওপেন করি. So you see drop in there, under it we have a couple of things we can put. ঠিক আছে? Okay, let me show you what are the things that we have put. Axis equals to 1. Now the default value of axis is 0. If I don't give axis as 1, then axis is 0. What does axis 0 mean? Axis 0 means it's going to delete that row. ঠিক আছে? আর axis 1 মানে it's going to delete that column. Am I clear নাকি না? Is that okay?
Yes, sir.
Yes. So over here you see that a unwanted যে কলামটা আছে সেটাতে প্রত্যেকটা এন্ট্রিতে there is a missing entry. আমি যদি রো ওয়াইজ সবকটা ডিলিট করতে চাই, কারণ প্রত্যেকটা রোতে তাহলে নান পাবেন, তাহলে আমি যদি অ্যাক্সেস ইকুয়াল টু 0 দেই তাহলে কি হবে? প্রত্যেকটা রো ডিলিট হয়ে যাবে না নাকি না? Yes?
Yes, sir.
But I don't want to delete the rows. I just want to delete this column. So I just say axis equals to 1. So it's going to find out the column which has nan and it's going to delete that column. Is it clear, Nakana? Yes?
Yes, sir.
Okay. Now there is another parameter here. It's called in place. By default, in place is always false. In place মানে হচ্ছে যে whatever I'm doing, এই যে data frame এর উপর যে I'm going to drop that particular column. So এটা কি ওই data frame কে update করবে নাকি it's going to just show me a temporary thing that's going to happen, but it's not going to update that. But I want my data frame to be updated. I want the data frame to delete that column. So I put the in place to be equals to true. Is it clear, Nakana? Yes? ঠিক আছে? Are we good?
Yes, sir.
Okay. So if we do that and then I print out the shape of that, let's see what happens now. If I do so, now you see, now I have got 569 instances. It's the same number of instances I have, but instead of 33 columns, I have got the 32 columns because this particular column has got deleted right now. Is it clear to all of us, Nakina? Are we good?
Yes, sir.
In fact, if you want to just see that, did it really happen? I can do that. I can just write df.head, okay, to print out the first 5 instances. If you do that, you see this time I do not have that unnamed column that I had. So the last column now, we had fractal dimensional worst, unnamed 320. Now the last column we have is fractal dimensional worst. That means that unwanted column has been deleted. Is it clear, Nakira?
Yes, sir.
Good. Now we're done with that. Acha. So let's do one thing. The next thing that we're going to do is let's actually divide the data set into X and Y, the dependent and the independent features. X means what? X are the features, right? Yes, that we use to predict Y. So X predicts Y. So Y is the independent feature and X are the, Y is the dependent feature because Y depends on X and X are the independent feature. So I'm going to separate both here, X and Y. So that's easy. So Y is this column is the Y, diagnosis, right? So I just wrote Y equals to DF, diagnosis. So this is Y. And what are X? X are the rest of the things. Now look at over here. When I write, so I don't want to take all, I do not want to take the diagnosis column. Apart from the diagnosis column, I want to take all the columns. So the way I do that, I write X equals to df.drop. Columns that I'm going to get rid of are ID and diagnosis. Can you see that? Because I don't want the ID as well. Right, Nakina? Yes?
Yes, sir.
Yes. What will X contain? X contain all those things except the ID and the diagnosis. Is this clear, Nakina? Yes? Yeah?
Yes, sir.
And Y will contain only the diagnosis part. Is that okay? Does it make sense?
Yes, sir.
Yes, sir.
Okay. So if I do a x.head, so if I print out the first five instances, you see I have got all those things: radius mean, texture mean. You see over here, radius mean, texture mean, all the columns except the ID and diagnosis, right? And Y would only have the diagnosis part, right, Nakina? So Y have the diagnosis part. Diagnosis is ki ache? We have got the diagnosis is either it's a malignant cancer or it's a benign cancer. Now, if I want to see if the data set is balanced or imbalanced, I can do y.value counts. So if I do value counts, so it tells me there are 357 instances of cancers which are benign and 212 of them are malignant. Okay? So this has a little bit of class imbalance, but anyway, we do not worry about class imbalance right now. Okay? Is it clear so far so good? Are we okay?
Yes, sir.
Yeah. Now, we would like to talk about this one right now. How can we divide the data set now into different parts and we actually do the performance analysis? Now, there are several techniques that we have. Okay, there are several techniques. In the last class, you've seen this as a technique. We take the data set, divide into two parts, train set and test set. Okay, this technique that you saw in the last class is what we call the holdout validation approach. So the holdout validation approach is a train test split that you have seen in the last class, right, Nakina? Yes. So let me show you, because we're talking about all those approaches that we have. So the first approach that we are now going to discuss, which we have seen actually in the last class, is the holdout validation approach, which is the train test split approach. So train test split approach ki kore? So it divides the data set into train part and test part. Okay. So we have something called train test split in sklearn. So if you want to import that one, so you have to from sklearn.model selection, you have to import train test split. And let's say we also want to do the analysis, or let's say we want to apply the decision tree classifier. So I'm going to import the decision tree classifier. Okay, and I'm going to just measure the accuracy. So I also imported from sklearn.metrics accuracy score. Okay. So in the train test split, what we're going to do is we're going to apply this train test split function, and it takes certain parameters here. X is the what? X are the independent features, Y the dependent features. So X and Y ta alada kore felchi agei. And now we have to specify what's the train size or the test size. যে কোনো একটা specify code the হবে. Let's say I'm specifying the test size to be 0.3, so 30% of it is the test set, and I'm also giving a random state value of 0, so you can give any value. ঠিক আছে? Okay, is it clear নাকি না? Yes? ঠিক আছে?
Yes,
Yes, sir.
Okay, so when you do that, when you apply this train test plate, what happens is this is what really happens. So when you apply the train test plate, so look at this. This is your data set that you have. Okay, the data set contains certain things. It contains X and Y. So you have got lots of features. Let's say X1, X2, up to Xn. So these are your features, and you have Y, which is the class, target class that you want to predict, right, Nakina? So these are your data set that you have. Is it clear, Nakina? Yes?
Yes, sir.
Right? Okay. So these are your X's, okay, and this is your Y that is there. Now, when you apply the train test plate, now something interesting happens. So when you apply the train test plate function, okay, now look at this one. What it does, I said that a train test plate function would take the data set and convert into a train set and a test set, right, Nakina? Yes, remember that? Yeah. Or actually what it does, yes, it does that, but a little more details to the key. It actually take this data frame. Now we have this as a data frame, right, Nakina? Yes, the data frame was called DF, right, Nakina? DF chilo na data frame tar ekhane. Yeah. Okay. It takes that one and produces 4 more data frames. So it's going to produce 4 more data frames. What are the data frames that it's going to produce? So there's a data frame called X train. That means train parted X value gola. These are the X trains. So that will form one data frame. Okay, right, Nakina? Yeah. It's also going to create another data frame called X test. So what is X test? What do you think? X test will comprise of the records of the X's, the features of the test data set. Clear, Nakina? Yes?
Yes, sir.
ঠিক আছে? Also, it will create another data frame called Y train. So what is Y train? Hello?
তো Y কলমে ট্রেনের জন্য যে ডাটাগুলো হলো সত্যি আছে
Can you hear me?
Yes, sir.
Yes, sir.
Yeah. Okay. Let me share my screen again. Okay, so you can see what's happening. Okay. Right. Okay, can you see my screen?
Yes, sir.
Yes,
Yeah.
sir.
Okay. So what happens is when you apply the train test plate, it produces 4 more data frames. Okay, X train, X test, Y train. Y train means what? The Y values of the train part, and there's another one called Y test, which are the Y values of the test data set. Clear, Nakina? So that's what the train test plate would do. It's going to create 4 more data frames. Yes. Is that clear, Nakina? Is that okay? Yes. Did you understand that, Nakina? Hello.
Yes, sir.
You have to respond. Okay. Did you understand this one or not? So you take the data
Yes, sir.
set, apply the train test plate. Yes, it converts into train set and test set, but this is how it creates 4 different data frames, and you are clear now what we have in each of these data frames. Is this okay, Nakina? Clear? Yes?
Yes, sir.
Okay, so let's go here. So this is what we do. We apply the train test plate. We specify the X value and the Y value. We specify the test set size, and we give a random state as well. And what happens when we apply this train test plate? It converts into 4 different data frames, and those 4 data frames are X train, X test, Y train, Y trace. So I stored them as X train, X test, Y train, and Y test. So these are the variables. You can call them other names as you like, but I would like to keep the names as X train, X test, Y train, and Y test. Is this okay, Nakina? Are we clear? Yes?
Yes, sir.
Yes, sir.
Okay. So now we have done this one. This is the train test plate or the holdout validation approach. Now, how do we measure the performance? Very simple. So this is something that we do. Let's start with a classifier. Let's say we want to apply the decision tree classifier. So we imported the decision tree classifier. So decision tree classifier, and let's say we initialize CLF as decision tree classifier. So CLF is your classifier. Now we want to use this classifier to create a model, right, Nakina? This is the algorithm. We want to create a model. How do we create a model? You have an algorithm here, which is the machine learning algorithm. That's the classifier. And you want to create the model. How do you create the model? You apply the algorithm on the train set. Okay. So that's what we do with the fit function. So when you say CLF.fit, so it takes that estimator of the classifier and it applies on the train part. Never apply the fit function on the test set, because you always want to create a model from the train set, right, Nakina? Yes. So you supply the X train and the Y train, and what happens when you actually fit that CLF? It creates a model. Is it clear, Nakina? Are we good?
Yes, sir.
Yeah. So now if you want to make a prediction, let's say how does it do on the unseen data? So what's the unseen data over here? So I'm going to see from the test set. Okay. So if we want to apply that from the test set, this is what I'm going to do. I have a function called predict. So I'm going to say CLF.predict. So that classifier, I'm using the classifier to predict. And what are the X test value I'm giving? What are the features I'm giving? The features are from the X test. So this is the unseen data set. So that's something that the model did not see. And X test is the একটা শুধু feature now. অনেকগুলো feature set, right? A number of features on the test set. So প্রত্যেকটা feature এর জন্য it makes a prediction and it stores all this prediction in whitebread. Is this clear, Nakina? Yes. So first test data জন্য the prediction is stored. Second test data জন্য prediction. So all those predicted values are stored in whitebread. Is this clear, Nakina? Yes. ঠিক আছে? আচ্ছা. Now, see over here from sklearn.matrix, I imported something called accuracy score. Now, what happens is when you apply this accuracy score, this accuracy score function takes 2 things. The predicted Y value, the predicted value by the model. So the model predicted that value whitebread. And what's the actual Y value? The actual value is the Y test, right, Nakina? Clear? ঠিক আছে? Yes, Nakina?
Yes, sir.
Yes. So what this function does, it takes a predicted value by the classifier and it takes the actual Y value and it actually compares and finds out the accuracy. Okay. So if we apply this one right now, let's see what happens. So when we ran that, we found that the accuracy to be something like 92.39%. Is it clear, Nakina? Are we good?
স্যার অ্যাকুরেসি ফাংশনটা কিভাবে কাজ করে? অ্যাকুরেসি স্কোর ফাংশনটা একটু আবার
স্যার
বলুন।
এটা কি খুবই ডিফিকাল্ট বুঝা? আপনার একটা হচ্ছে প্রেডিক্টেড ভ্যালু আর একটা হচ্ছে অ্যাকচুয়াল ভ্যালু। আপনি নিজে চিন্তা করে দেখেন, এভাবে চিন্তা করেন। এখানে ওয়াই কি ম্যালিগন্যান্ট বা বিনাইন? হ্যাঁ, আপনার ধরেন প্রেডিক্টেড ভ্যালু প্রথমটার জন্য আসতেছে ম্যালিগন্যান্ট, সেকেন্ডটার জন্য হচ্ছে ম্যালিগন্যান্ট, থার্ডেরটা হচ্ছে বিনাইন, ফোর্থেরটা হচ্ছে ম্যালিগন্যান্ট, ফিফথেরটা হচ্ছে বিনাইন, লেটস সে। ওকে, আর আপনার অ্যাকচুয়াল ভ্যালু যেটা আপনি ওয়াই টেস্ট হিসেবে রাখছেন সেটা হচ্ছে আসলে দিস ইজ ম্যালিগন্যান্ট and it predicted is malignant. Let's say this is benign but it predicted it's malignant. Let's say this is benign, let's say this is malignant, let's say this is malignant. তাহলে বলেন কতগুলা মিললো এখান থেকে? একটা মিললো, দুইটা মিললো, তিনটা মিললো, রাইট নাকি না? ইয়েস, তিনটা মিলেছে আউট অফ হাউ মেনি? 1, 2,
Five.
3, 4, 5. So what's accuracy? 3 out of 5. Okay. So all you require is y pred, যে values গুলো আছে এবং y টেস্টের যে values গুলো আছে, you can make them to compare and find the accuracy, right? That's what that accuracy score function do. Is it clear নাকি না? Yes. Okay. মানে if you want, we could have written the function which would do that, but actually scikit-learn has all those functions, so we can just use those functions to find the accuracy. But I hope you, I think that was the question, তাই না, যে এই accuracy score actually accuracy টা measure করে কেমন? Is it clear নাকি না? Yes.
Yes, sir.
Okay. So that's what it did, and we found the accuracy to be 92.39%. Is that okay to everybody? Yes.
Yes,
ঠিক
sir.
আছে? আচ্ছা, so that was one approach we have seen, which is called the holdout validation approach or the train test split. Okay, so that's one way we can actually divide the data set and we can do some performance analysis. Let me show you another very interesting strategy called the k-fold cross validation technique. Okay, so let me explain you the k-fold cross validation technique first, and then we'll look into the code. Okay, so প্রথম টেকনিক তো ক্লিয়ার সবার, তাই না নাকি না? Is that okay? Yes. ঠিক আছে?
Yes, sir.
Okay, now I'm going to explain you a very, very, very important technique, which is called the k-fold cross validation approach. K-fold cross validation technique, we are not going to split the data set into two parts. Train test split, we divided the data set into two parts, train part and test part, right? Yes. Okay, but in case of k-fold cross validation, we are not going to do that. Is it okay, Nakina? Yes. We're going to do something else. What are we going to do? Okay, let me show you what we are going to do. So this is called k-fold cross validation. Now, let's think about the data set that we have. This data set. Okay. Yes. Acha. Now, I will say this is not the raw data set, but this is the pre-processed data set. যেটার উপর আমরা different sorts of machine learning algorithms apply করব, right? Nakina. So this is the pre-processed data set that we have. Is this okay, Nakina? Clear? Yes. ঠিক আছে? Are we good? Can you hear me?
Yes, sir.
Yes, sir.
Yeah, you have to respond. Is it okay that this is your data set that you have? You have got lots of X and Y's written over here. So these are, this is different features, X1. So I'll write it over at the top. So this is here. So X1 feature, X2 feature, up to Xn features, and the corresponding Y values. All these things are stored over here in this pre-processed data set. Is it okay, Nakina? Clear? So far, so good. Acha. Now, in a k-fold cross validation, here is something called K. K has a value. So you can give any value. You can supply K as 5, K as 10, K as 3. So if you put K as 5, it would be a 5-fold cross validation. If you put K as 10, it's a 10-fold cross validation. Typically, we use 10-fold cross validation or 5-fold cross validation. Okay, but let me now explain you what does this 5-fold cross validation or 10-fold cross validation. What is this k-fold cross validation approaches? Now let's say I'll take K as 5 as an example. When I do k-fold cross validation, or in this case 5-fold cross validation, it will take my entire data set that we have, and it will divide this data set into five equal folds. Okay, so it will divide this one into 5 equal folds. So here's one part, one fold, second fold, third fold, fourth fold, and fifth fold. 1, 2, 3, 4, 5. Is it clear, Nakina? 5 ভাগে ভাগ করলো. Is it okay? Yes. Sir.
Yes,
if
sir.
you don't respond, it's not going to work out this way. ঠিক আছে? Okay. Is it clear? এখন এই যে 5-fold আমি যেভাবে 5টা ভাগে ভাগ করেছি, এটা যে পরপর সবকটা রোকে দিবে তা কিন্তু না। ঠিক আছে? It depends on the random state, but I'm just, for simplicity, I'm just showing you this way. Okay? So it divides into 5 equal parts. Is it okay, Nakina? Clear? Are we good?
Yes.
এটা কি লো
Okay.
ওয়াইজে হতে পারে, কলম ওয়াইজ হতে পারে কি ফোল্ডে?
আরে বাবা, পুরো ডেটা সেট এখানে XY পুরো ডেটা সেটকে আমি 5 ভাগে ভাগ করছি। ঠিক আছে নাকি না? ক্লিয়ার? ওকে? Is that fine? Okay. Now, এখন যেটা করবে k-fold cross validation, it will take one of the folds and say this is the test set. It will make it the test set. And the remaining folds will be the train sets. Am I clear, Nakina? Yes?
Yes, sir.
Now it will take these folds, the train folds, to actually create a model. Is it okay? That decision tree classifier or any other classifiers or estimators, okay, apply on this train part, okay, and create a model. And that model gets evaluated on this test fold, right, Nakina? This is the test fold that evaluates this. Is it clear, Nakina? Yes?
Yes, sir.
Okay. So once you do that, you get a result, Nakina. At accuracy score, Papa. Accuracy. Yes. Okay. Correct?
Yes, sir.
Okay. Then what it's going to do is it's going to change the test set. It's going to say, okay, let's not make this as the test fold. Let's make this as the test fold now. Okay. And the remainings are the train fold. So this is the train fold and these are the train fold altogether. Okay. And so you get another accuracy for this particular fold. Is that right, Nakina? So you have accuracy 1, accuracy 2. So in this way, how many accuracies would you have?
5.
K number of accuracies. Yes. If you choose K to be 5 accuracies. But in general, you have K accuracies. Is it clear, Nakina? Yes?
Yes, sir. Yes, sir.
Okay. Now, what is the overall accuracy therefore? Then you take the average of this accuracy, which is the overall accuracy of this, model. Okay. Is it clear, Nakina? Are we good?
Yes, sir. Yes, sir.
Okay. So this approach is what we call the K-fold cross-validation approach. এটা clear হয়েছে আপনাদের নাকি না? Clear হয়নি?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So K-fold cross-validation approach is sometimes has certain advantages over the train test split. Train test split আপনার train part এবং test part এ divide করে ফেলছেন, তাই না নাকি না? Yeah. K-fold cross-validation এ কিন্তু আপনি যেটা করছেন, এখন ডিস্ট্রিবিউশনের যদি খুব মেজর ডিফারেন্স থাকে, ডেটা সেটে ডিস্ট্রিবিউশন যদি খুব মেজর ডিফারেন্স থাকে, আর এমন যদি হয় একটা এন্ড তোমার ট্রেন পার্টি টেস্ট পার্টি চলে গেছে, অন্য একটা ডিফারেন্ট ডিস্ট্রিবিউশন ট্রেন পার্টি গেছে, তাহলে কিন্তু তোমার ক্লাসিফায়ারটা খুব ভালো রকম কাজ করবে না, ঠিক আছে? বাট কে ফোল্ডে বারবার চেঞ্জ করছি দেখে এবং ইউ আর টেকিং দ্য এভারেজ ওয়ান, ঠিক আছে, দি অ্যাকুরেসি ইজ মাচ মোর রিলায়েবল, ঠিক আছে, সামটাইমস ওভার the train test split. Is it clear? But not always. K-fold cross-validation, that's the advantage of K-fold cross-validation, but train test split also has certain advantages. But in any case, we'll not go to the advantages right now. But is the K-fold cross-validation technique clear to all of us or not? Tell me the idea. Is that clear?
Yes, sir.
Yeah. So now let's see, if we want to apply the K-fold cross-validation, how do we do that? So from the scikit-learn's model selection, you have to import something called K-fold. ঠিক আছে? Okay, right? Because we are applying the K-fold cross-validation. আর এখন cross-val score, আগে তোমার score measure করার জন্য accuracy score use করেছি, but this time we are going to use something called a cross-val score. So we are going to import that as well. Is it okay, Nakina? Clear? Yes? Okay.
Yes, sir.
So now we also import the NumPy. We'll see why we import the NumPy. We'll see that. Now, I'm going to now say, K-fold cross-validation, K koto. Are we going to do for 5-fold or 10-fold or 15-folds? Let's select one K-fold. K, let's say 10 folds kori. So we have this function called K-fold. K-fold function mode ekhane specify kora jaচ্ছে number of splits, number of folds. This is actually the, so if I go press Shift Tab, okay. What happened? Okay. All right. Okay. In any case, so K folder jodi ami iya dekhte chai, it's not coming. So if you go to say if I just write K fold, this is what you can do. sklearn, you just type it up. So you go there and you'll see K fold from sklearn.model selection থেকে import K fold. N splits. What is N splits? N splits is the number of folds. You're specifying the number of folds. Is it clear, Nakina? Yes? Okay?
Yes, sir.
Acha. And you can also give a random state, but let's say if you want, you can give a random state. Right now, I'm not giving any random state. So we say, so we're going to create a K fold with number of splits koto 10. তাহলে কতগুলো fold তৈরি করছি? 10 folds cross validation করব, right? এবং এটাকে I'm storing in a variable called k-fold validation. So how much cross validation am I doing? What's the k-fold? It's a 10-fold cross validation we're gonna do. Is it clear, Nakina? Yes?
Yes, sir.
Sir, you got to respond faster, okay? Now, let's instantiate the decision tree classifier. So CLF equals to decision tree classifier. So CLF is the decision tree classifier. And now we're going to use this function called cross-val score. Cross-val score, and this cross-val score function is going to take three things, okay? You see over here, cross-val score. So if we go back again over here, and if we write scikit-learn cross-val score, let me show you. So just type in sklearn, and I'll write cross-val score, right? It will take you to the documentation. What does a cross-val score do? It evaluates the score by cross-validation, right, Nakina? Clear? And it takes a couple of things. প্রথম জিনিস কি দিচ্ছে দেখেন তো, what does it take? The first thing, estimator, that is যে কোন অ্যালগরিদমটা ইউজ করছি. So what algorithm am I using? I'm using the decision tree classifier, which is CLF. So I have given the estimator we are using is CLF, which is the decision tree classifier, right, Nakina? Yeah, it's okay. Second parameter কি আর কি নিচ্ছি? X এর ভ্যালু নিচ্ছি আর Y এর ভ্যালু নিচ্ছি. So I'm giving you the values of X and Y. So X is X and Y is Y. এটা আগে X কোনটা আর Y কোনটা বলে দিয়েছি, right? Okay. Also, we need to specify কত fold cross validation করছি, right, Nakina? Okay. That means we have to give the cross validation, কত fold cross validation করছি. So কত fold cross validation করছি, that's actually stored over here in k-fold validation, right, Nakina? So CV, the cross validation is k-fold validation, which is actually 10-fold, right, Nakina? Clear? Is that okay?
Yes, sir.
That's it. Done. So when you do cross-val score, it will actually 10টা আলাদা fold বানাবে. প্রতিবার একটা ফোল্ডকে টেস্ট সেট নিবে, বাকি 9টা ফোল্ডকে কি ট্রেন পার্ট করবে, ট্রেনের উপর ট্রেন করবে, ট্রেন ডেটা সেটের উপর ট্রেন করবে, করে মডেলটাকে টেস্ট সেট দিয়ে ইভালুয়েট করবে. তাহলে এরকম কতগুলো রেজাল্ট হবে? 10টা. Good. And they are all stored in this variable called results. And I also printed out the results. So this will print out a 10টা folder উপর accuracy কেমন ছিল. Is it right, Nakina? Yes. So if I run this code a little bit, you'll see that. So you see, it printed off the results, which has the first প্রথমটার জন্য we get a 91.2% accuracy. Again, similar accuracy. A little bit low, little bit high. Okay, there will be variabilities. তাই না, Nakina? Yes. So you're getting this. Clear, Nakina? Yes. So 10টা আলাদা আলাদা accuracy পেয়েছেন. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So you get 10 different accuracies. Now, how do we then say what is the accuracy? So you have k accuracies. So you need to take the average of these k accuracies. Okay. So how do you take the average of k accuracies? So the way we can take that is I'm going to print out results. So say np numpy dot mean results. A results যে 10টা আছে সেটা mean value নিচ্ছি, plus or minus I also find out what's the standard deviation. So we can now say that the accuracy is 92.437% plus or minus 0.0335%. Okay, so a good advantage of this k-fold cross validation is we do not get one accuracy. Okay, we get a plus minus standard deviation. So আমি একটা narrow band পেয়ে যাচ্ছি যে কত পার্সেন্টেজের মধ্যে we can expect what's the accuracy, তাই না, নাকি না? Clear? Yes. Did you understand this one, Nakina?
Yes, sir.
Okay. Did you understand, everybody, what's the k-fold cross validation?
এর মানটা যে কম বেশি নেওয়ার মধ্যে ইয়াটা কি, বেনিফিটটা কি? মানে আমি কি এর মান 20 নিতে পারবো, 100 নিতে পারবো বা এরকম?
So if you want, you can do one thing. সেটা হচ্ছে you can do a bit of experiments. ঠিক আছে? আপনি k এর ভ্যালু একবার 5 দিয়ে করেন, একবার 10 দিয়ে করেন, একবার 15 দিয়ে করেন, একবার 20 দিয়ে করেন, ঠিক আছে? করে একটা গ্রাফ আঁকেন। ওকে, প্লট করেন। প্লট করে দেখেন যে which k value would give you better accuracy. Usually কাছাকাছি পাওয়ার কথা। Is this okay, Nakina? Clear? But if you are interested to test the sensitivity of the value of k, this is what you should do. Is it clear, Nakina? Yeah?
Yes, sir.
So because it varies from one data set to another data set, so but you can do the sensitivity test very quickly. So different k values, you do that and then plot an accuracy graph, and you see how for what different values of k, what kind of accuracies you get. That also gives you an idea of what value of k is most suitable for this. Is it clear, Nakina? Okay. Are we good?
Yes, sir.
Yes, sir.
Okay. All right. Later on, I'm going to talk about something called hyperparameter tuning. That's when we're going to talk about these issues as well. Okay. Which value of k would be better and things like that. Okay. Achha. But you get the idea, right, Nakina? Yes? Hello? ঠিক আছে?
Yes,
Yes,
sir.
sir. Yes, sir.
Acha. Now, there's a third strategy that we're going to talk about. First, আমরা কথা বলেছি সেটা হচ্ছে train test split. Second, we spoke about k-fold cross validation. Third, we are going to talk about a particular kind of k-fold cross validation called the stratified k-fold cross validation. Now, what is a stratified k-fold? Can you hear me?
Yes, sir.
আজকে আমার সাইডে net is net না actually electricity is down and everything is down. ঠিক আছে? Anyway, but I hope you can see my screen now again. Can you?
Yes, sir.
Okay. K-fold cross validation to the clear. Nakina, clear now. Is that okay?
Yes,
Yes,
sir.
sir.
Yeah. So we're gonna see what is stratified K-fold cross validation. Okay. Stratified cross validation, K-fold cross validation is suitable if you have imbalanced data. If you have imbalanced data. Now, why do I say that? If you have imbalanced data, or if you have imbalanced data set. Let's imagine you have a data set. So let's take an example and you'll understand why is this important. Let's say you have a data set and there are 1,000 samples. Is this okay, Nakina? Altogether, it has 1,000 samples, right, Nakina? Yes? ঠিক আছে? আচ্ছা। এবং এখানে target class A হতে পারে বা target class B হতে পারে. Let's say we have got two kinds of target classes. I have target class called A and I've got a target class called B. Is it okay, Nakina? So how many target classes can we have? Two different kinds, A and B. Let's imagine আমার 1,000 samples এর মধ্যে 990 samples belongs to class A and 10 samples belongs to class B. Is it okay, Nakina? Yes?
Yes, sir.
তাহলে can I say that this data set is highly imbalanced? Yes?
Yes, sir.
Now, এইসব imbalanced data set, you need to be very, very careful because if you apply a train test split, what's going to be the problem? Can anyone think about a problem of using a train test split on this sort of imbalanced data set?
স্যার অনেকটা বায়াস রেজাল্ট দেবে।
কেন হবে? Train test split কি করে? Train test split is going to take your data set and divide them into what? Train part and test part, right? Yes?
Yes, sir.
এখন দেখেন ক্লাস এ তে হচ্ছে ম্যাক্সিমাম অফ দ্যাট এবং যদি ট্রেন পার্টে সব ক্লাস এ আসে এবং ক্লাস বি যদি একটাও না আসে বিকজ ক্লাস বি এর সাথে খুব কম ইজ ইট ক্লিয়ার নাকি না
Yes, sir.
তাহলে কি হবে তাহলে ট্রেন পার্টে যদি সব ক্লাস এ আসে তাহলে উইল ইওর মডেল লার্ন এনিথিং অ্যাবাউট ক্লাস বি
No, sir.
No, you have to have some representatives of class B in order to learn about class B as well, right, Nakina? Yeah, but because it's randomly sorted out, কোনটা কোথায় যাবে, It could just happen that there is no class B in the train set at all. Yes or no, right? So that could be a problem. Is it right, Nakina? Yes?
Yes, sir.
Yes, sir.
If you apply K-fold cross validation, you can still have a problem. Why you can still have a problem? Because K-fold cross validation, ধরেন 5টা fold করলাম. So these are the 5 folds, 1, 2, 3, 4, and 5. So if you have 10 samples of class B, you need to have at least 2 of them in each of these folds. তাই না? Equal representative থাকা উচিত. তাই না নাকি না? Yes?
Yes, sir.
এখন যদি হয় কোনোটা নাই, মানে ক্লাস বির কোনো স্যাম্পল নাই ইন দ্য ফার্স্ট ফোল্ড, কোনো স্যাম্পল নাই সেকেন্ড ফোল্ড, 3টা আছে এখানে, ওকে, 7টা আছে এখানে, এখানেও কোনোটা নাই, তাহলে সমস্যাটা কি হবে? সমস্যাটা হচ্ছে এই 1 and 2 and 5 এগুলাতে যদি কোনো ধরনের ইয়া না থাকে, কি বলে, these samples না থাকে, এই স্যাম্পলগুলো না থাকে, then again we could not actually uniformly distribute this minority class over these folds, right, Nakina? The same problem that we have in the train test plate, we could not actually uniformly distribute over the train part and the test part, right, Nakina? Yes? ঠিক আছে? So the same problem retains over here. Now what a stratified class K-fold cross validation do is it solves that. It ensures that যতগুলা class আছে, their equal representations are available in each of the folds. Is it clear, Nakina? Yes?
Yes, sir.
Right. Otherwise, তোমার দেখা যাবে এখানে সবকটা হচ্ছে এখানে ক্লাস A এর আছে, B এর কেউ নাই. Now that's weird. Then that's a problem, right? Okay. We need to have equal representations, and that's what exactly this stratified K-fold cross validation would do. Okay. So I would just mention over here, stratified K-fold cross validation is definitely your choice if there is an imbalanced data set, right, Nakina? Clear? Okay.
Yes, sir.
So I'll write it here for imbalanced data set. Okay. I'll write for imbalanced data set. So you know, if you have an imbalanced data set, you should go for stratified K-fold cross validation technique. Okay. So the idea is as before, programming wise, it is as before. So I'm going to show it over here. From scikit-learn.model selection, this time you are importing stratified K-fold. আগের বার you imported only K-fold, right, Nakina? Because you were not interested in stratified K-fold. But this time you are importing stratified K-fold. So then how many splits you're going to do? Let's say you want to split 5 times. You want to create 5 folds, so you're going to do not K-fold, stratified K-fold, and n splits as 5. Okay, store them in SK-fold, and this is your classifier, which is a decision tree classifier. Same thing. Apply the cross-val score the same as before. Put your estimator or the model, which is CLF, give the X and Y. And the cross validation is this time SK-fold, which is the stratified K-fold cross validation. Is it clear, Nakina? Yes?
Yes, sir.
Okay. So how many results would we be expecting?
5.
5. Right? Good. Because each time, one of them would be a test fold, and the remaining are the train folds, right? So we get 5 different results, okay? So we can print the results, and basically when we want to really print out, so instead of printing out 5 different results, I should take the average and also specify the standard deviation. So np, the numpy.mean of results would give the average, plus or minus np.std, standard deviation of results, that will give you the standard deviation. So if I run that one, I see these are the 5 accuracies we get. 0.903508777, 0.90 this, 921, 94, 920. And now you see that the accuracy is this much, right? Now, if you compare a little bit with this one, you see it can 0.87 last year, but this is better. It can 87% by 89% কোনো কিছু নাই, ঠিক আছে? সব কিন্তু 90% এর উপরে, ঠিক আছে? Because of the equal representation of the different classes you had, okay? You had better, result, okay? Now you can say এখানে average result of একটু higher আসে, কারণ এখানে class imbalance ইস্যুটা খুব বেশি না. But if you really had a class imbalance issue, okay, stratified K-fold cross validation would really improve your accuracy. Is it clear, Nakina? Yes? Understandable?
Yes, sir.
Okay. Let me show you one more technique, okay? Another way you could split, which, 2 more techniques. So what is called the leave one out of one out cross validation. Now this is something I will never recommend you to apply, ঠিক আছে, especially if it's a large data set, because it's the slowest technique that you have. Leave one out cross validation টেকনিকটা কি করে, কে ফোল্ড যেমন কি করে, ডেটা সেটটাকে নিয়ে কে ডিফারেন্ট ফোল্ডস ক্রিয়েট করে, তাই না নাকি না? ইয়েস, রাইট? ঠিক আছে নাকি না? ইয়েস,
Yes, sir.
Yes, sir.
but leave one out cross validation কি করবে? Leave one out cross validation is going to do this one. Now here's the data set that you have. Let's say x1, x2, and you have such xn features, and this is the y. So you have so this is the first instance, okay, whatever the values, second instance, another value, third instance, whatever. So you have so many instances. So for each instance, now it's called leave one. So এইটাকে প্রথমটাকে ধরো, it chooses this as a test set, and the remaining ones are then the what, train set. Second iteration the second row যেটা সেটা এখন হচ্ছে test set, বাকি সব train set. তাহলে এটা কতবার রান করবে মনে হয়? How many times do you think will it run? তোমার ডেটা সেট যত বড় হবে ততগুলা, তাই না নাকি না? Is this right?
Yes, sir.
Yes. Okay. So if your data set has 500 rows, let's say, so every time, every iteration, একটা রোকে সে test set হিসেবে দিবে, বাকিগুলোকে train set. So it's going to do for all the rows, so it's going to run for 500 times. ঠিক আছে নাকি না? Clear? So now imagine if you have a big data set with so many huge number of rows, billions and billions of rows. This is going to be a very slow approach, right? Naki na? Clear? Is that understandable? Yes?
sir.
Okay.
Yes, sir.
So that's something I usually never recommend you to use, but it's a technique, so I'm just showing you. Okay. So it's not recommended for large data set. So this is what we're going to do. From sklearn.model selection, you have to import leave one out. Okay. Take the classifier, which is a CLF, leave one out. Let's say we store it as save it as leave. Then I'm going to apply the cross-val score. The classifier is CLF, the X, Y, and the CV is now this leave, which is leave one out. Now, if I print the result, how many results do you think will I get? যতগুলা rows আছে, এর মধ্যে কতগুলা rows আছে? How many rows did we see?
560.
Yeah, 569 rows, right? নাকি না? Yes. So you should have 569 results, right? নাকি না? Yes. ঠিক আছে? Okay.
Yes, sir.
So I printed out the results. You'll have 569 results, but of course I don't want you to count it. So it can tell the length of results, length of that results course. I think you'll get 569, but of course you find out the 569 results, but you want to show the mean of them. So you take the mean of that plus or minus the standard deviation. So if you run this one, it's going to be a little slow, as I said. 569 rows is not a lot, but you can see already it's a bit slow, right, Nakira? So it's definitely something that I would not recommend. Okay. Now that's it. You see that there are 569 actually results. In fact, okay, you can count out all these results, but I'll not count whether there's 569. There is 569 results. These are the results, and that's the accuracy that you get. Is this clear, Nakina? Yes. Are we good?
Yes, sir.
Good. Great. So we understand this. Okay. Now, last idea, another idea we can apply. There's something called shuffle split. Shuffle split is the same idea as that we have seen in the train test split. But train test split আমরা কি করেছিলাম? We took the data set and we divided this data set into train part and the test part. Am I correct, Nakina? Yes? Yes?
Yes, sir.
Okay. But now if I do this training 10, couple of times, repeated number of times, ঠিক আছে? তাহলে I have what we call repeated random train test split, or we call it the shuffle split. Okay, so here's the idea of the shuffle split here. From sklearn.model selection, you import shuffle split. So your S split, which is a shuffle split, is shuffle split. We have said that কতবার repeat করব এই ইয়েটা কি বলে এই ট্রেন টেস্ট স্প্লিট 10 বার বলে দিয়েছি 10 বার, and I'm also mentioning the test size. ঠিক আছে নাকি না? Yes. Okay. All right. So we say the test size is 30% and 10 বার repeat করবেন. The classifier is decision tree classifier. Again, I'm applying the cross-val score. I'm giving the classifier CLF, X is X, Y is Y, and cross validation technique is that shuffle split. Okay? So what it will do now is it's going to, apply a train test split, okay, find out the result. Again, apply again a train test split, find out the result. It's going to apply this train test split on the data set 10 times. Okay, so how many results would you be expecting now? 10 results. Yes?
Yes,
Are you
sir.
guys there? Yeah. And then you simply print out the results. You can print out the average and the standard deviation. So these are the 10 results. And if you find that the average and the standard deviation 92.22% plus or minus 2.04%. Okay, is it clear?
স্যার ওইটা কি এই যে 10 বার যে স্প্লিট করবে স্যার এটা কি 10 বার শাফল করে স্প্লিট করবে?
হ্যাঁ, of course, yes. ঠিক আছে, শাফল যদি না করে প্রত্যেক করতে সেম রেজাল্ট পাবে, তাই না? তাহলে তো কোনো দরকার ছিল না, শাফল তো এই জন্যই করবো আমরা। ঠিক আছে, ওকে, রাইট। সো এই জন্য এখানে কোনো শাফল স্প্লিটে কোনো র্যান্ডম স্টেট আমরা দিচ্ছি না। You see that, নাকি না? Yeah, okay, I hope it's clear, right, নাকি না? Yes.
Yes, sir.
Yes,
So
sir.
we have learned different ways we could actually, take a data set and evaluate it. Train test split, cross validation, K4 cross validation, and now we have got something called a couple of things. Leave one out cross validation. We also have something called shuffle split. There are a few more examples as well, like leave P out cross validation, but that's okay. These are the main ones that you have. Okay, all right, clear? Are we good?
Yes, sir.
Yes, sir.
Okay, fantastic. So if that's clear, so this is clear to all of us. Okay, no problem. So this is clear to all of us. Great. Okay. So now what we're going to do is we're going to discuss something called feature selection algorithms. Okay. All right. So let's get started with feature selection. Okay. And we'll talk about feature selection. It's a very interesting idea. So let's start. Okay. Let's go to the Anaconda prompt. Directory, CD, ML, teaching, yes, the notebooks, I guess. Yeah. Okay. Yeah. Teaching. Okay. Right. What we have. Feature selection is something we want to see. So I'll go inside that feature selection. Okay. All right. So this is where we are about to open the Jupyter notebooks. I'll just write Jupyter book. Start. Okay. Are we good? Okay. So we are now going to look at something called feature selection techniques. Okay. Now I don't think we will be able to complete this, but at least we want to see the first two algorithms in this feature selection techniques. So we want to see that at least today. Okay. So let's see what is feature selection first of all. Now, understand this one because this one is extremely important. Okay, and this would be very, very important when we are going to do the hands-on exercise on Friday. Okay, all right, so let me explain you what is the idea of the feature selection. So the idea is very simple. So first thing that you do is you collect data set, right? So when you collect data set, you have got certain features, right? So the features are x1, x2, x3. Let's say there are n features you have, right? Yes. Clear? Are we good? Nakina? Yes?
Yes, sir.
And let's say you're using classification, you're solving a classification problem. So you've got y, which is a class variable you would like to predict. Is that right, Nakina? Yeah? So that would now make your entire data set. Okay? That would make your entire data set now. This is your data set. Okay? You've got many instances. So for each instances, you've got all these features and you've got the third class. Is that right, Nakina? Correct? Yes?
Yes, sir.
Now, very important thing, are all features important to predict y? Maybe not. Maybe there are certain features which are not at all good. Like I said, there are certain features which you do not want at all. Right, Nakina? Nakina? Yes?
Yes, sir.
And now you may say, okay, feature ko thakle oshubida ki. Maybe because of the presence, what happens, it's more acting like a noise, okay? And it's reducing your error reducing your accuracy. Is this clear, Rakina? Yeah. So what we need to do is we want to find out, once we have collected the data set, we want to find out which features are my important features. Which features are my important features? Okay. Now, what is the definition of important features? How do you know, Mane, which features should I treat as an important feature? So what is the definition of important feature? I mean, which features would maximize my accuracy? Is that right, Nakina? So those features are my important features. Am I correct, Nakina? Yeah?
Yes, sir.
So what we are essentially going to see now is, once we have created a data set, we want to find from the data set, okay, before we even apply the machine learning algorithms, we want to know kun feature gulake I should have selected, kun feature gulake I should drop. Is it right, Nakina? That's the problem that we have, which is called the feature selection problem or feature selection algorithms. Okay, Nakina? Yes? So this is what the feature selection algorithms would do. Feature selection algorithms would find out good features that you should use in your machine learning algorithm, and it will also identify features that you should not use. Is this clear, Nakina? Are we good? Yes.
Yes, sir.
So we are clear about the purpose, right, Nakina? So it's a very, very important thing in machine learning. So we're going to see how to do that. Okay. Now we know what is feature selection by now. So you also understand that there are several benefits of feature selection. I'm going to give you some of the benefits right now here. One of the benefits that you have in feature selection, okay, let me actually clear the output. Okay, so everything's gone. Okay. So, okay, so some of the advantages of feature selections are it reduces overfitting. Okay, so it reduces overfitting. Overfitting কখন হয়? Overfitting হচ্ছে when you are trying to make it more complicated than its usual. ঠিক আছে? Okay, তার মানে when you are dropping the unimportant features, then there are less redundant data. Okay, meaning that there is less opportunity to make decision based on noise. And that's what means. This is what implies that we will be reducing overfitting through feature selection. So that's one thing that we should do. It also improves accuracy. We also already have discussed that one. Okay, Nakina, is it clear so far? Yes. Hello.
Yes, sir.
Yes, sir.
Okay. Third one, it reduces training time. Of course. So if you're getting rid of certain features, the number of elements we have in the entire data set কমে যাচ্ছে না অনেক, যত elements কমে যাবে তত তোমার it's going to be faster, right, Nakina? Yes. So reduces the training time. Less data would mean that the algorithm would now train faster. Is it clear, Nakina? So there are certain advantages we can see with the feature selection algorithms. Is it okay, Nakina? Yes.
Yes, sir.
Sir, চুপচাপ থাকলে হবে না. Are we clear or not clear?
Yes, sir.
Yes, sir. Now, there are many feature selection algorithms, okay? In this notebook, I'm presenting you 4 feature selection algorithms, but I don't think we will be able to cover 4 feature selection algorithms today, but we want to cover the first two algorithms at least, okay? Achha. So the first one is called dropping constant features using variance threshold techniques. So there is a technique called the variance threshold technique, and we're gonna use this variance threshold technique to drop constant features. So let me explain you what does it mean, okay? So it's a very simple technique. So I'll just go straight into the code because you'll understand everything, okay? First, let's create a data frame. আমরা একটা data frame create করি. So this is what we're doing. So this is how you can create a data frame in Python as well. So you first of all import pandas as pd, then pd.dataframe, and these are the column names. Column A, column B, column C, and column D. Okay, column A values go to 1 2 4 1 2 4, column B values go to 4 5 6 7 8 9, column C values go to egola, column D values go to egola. You have to make sure that each of these lists, each of these columns that you have the same number of elements, right, Nakina? Yeah, that's it. Okay, and you save this data frame in something called data. So data is your data frame. In order to just see how does the data frame look, Hello, can you hear me now?
Yes, sir.
Yeah, this is terrible today. Okay, let's see. Okay, so here we are. Right, let's go over here. Now, so as I was saying over here, can you see my screen? You
Yes, sir.
die. This is awful. Listen. So we are creating a data frame with 4 columns A, B, C, and D. A তে হচ্ছে এগুলো আছে, B তে এগুলো আছে, C তে এগুলো আছে, D তে এগুলো আছে. That's how you create a data frame and store the data frame. The name of the data frame is data. So when you print data out, so this is what you get. So this is a data frame that's created. Is it clear নাকি না? Can you see that?
Yes, sir.
Okay, so these are the features. Let's not worry about the target variables. Let's say these are the features. Okay, আচ্ছা এখানে একটা জিনিস দেখেন, কয়টা ফিচার আছে এখানে?
4টা।
চারটা, A, B, C, and D. Now, interestingly, look at feature C and feature D. There's an interesting thing in feature C and D. What are those things? Can you tell me?
Connected।
0 and 1.
So feature C সবকটা ভ্যালু একই, আবার feature D সবকটা ভ্যালু একই, right নাকি না? Yes.
Yes, sir.
So these are called the constant features. So this is what we call constant features. Okay. So these are the constant features. Now, do I need constant features?
No, sir.
Why not? Why do
স্যার
we
এগুলো
not?
তো সবসময় একরকম থাকবে।
Exactly. Say you're creating a data set. Right? Data set একটা feature আছে gender. Right? এবং দেখা যাচ্ছে জেন্ডারের প্রত্যেকটা এন্ট্রির ভ্যালু এন্ট্রি হচ্ছে মেল। সো প্রত্যেকটা এন্ট্রি যদি মেল থাকে তাহলে আলাদা করে জেন্ডার নামে কোনো ফিচার থাকার কোনো দরকার আছে? There is no variation at all. তাই না নাকি না? ক্লিয়ার নাকি না? Yes? বুঝতে পারছেন
sir.
আমার কথা? So
Yes, sir.
this is now all are main. So I would say this is a zero variance feature. So these low variance features are something we do not require, right? নাকি না? Clear? Yeah?
Yes,
Yes,
sir.
sir.
Okay, so one simple idea is get rid of these zero variance features. Okay, now, okay, so you can write a code from the scratch, but scikit-learn has something called here we are. If we open this in new tab, there's something called variance threshold. Okay, so you have to from sklearn.feature selection you have to import variance threshold. Okay, and you have to specify the threshold value. I'll show you. So if I am applying this one for this one, so on this data set, on this data frame, so I'm going to first of all from sklearn.feature selection I have to import variance threshold. As you see here, from sklearn.feature selection import variance threshold. So I've imported that one. Is it okay? Yeah. By default, the threshold value that we give over here in the parameter is 0. So variance threshold, that by default the threshold value is 0. 0 means zero variance. Okay, like here there is no variance, zero variance, so the threshold is 0, right? Nakina, yeah. But if it so happens to me low variance to me bad digits 0.1, you can actually give a value for the threshold. So right now I just want to drop the constant features. So for constant features the threshold is 0. So I'm going to now Okay, can you hear me now?
Yes, sir.
This has been terrible today. Terrible. সবাই চলে গেল এটা চলে গেল। যাই হোক, I wanted to finish off 2 of them, but I can't finish it. Okay, so let me just show you variance threshold. Okay, let's get rid of variance threshold. We'll not do the second one today, although I wanted to. Anyway, let's just show it very quickly. So I import variance threshold. By default, the variance threshold, the threshold value of the variance threshold is 0. So I'm going to create initialize variance threshold. So I store it in var underscore thresh. You can put it anywhere. So that's variance threshold. The threshold value is 0. So now if I say var underscore thresh, which is this one, dot fit and data. Data is the data frame that we have, right? This is the data frame that we have. Yes. Okay. So when we do that, hello, can you hear me?
Yes, sir.
Okay, let's do that. Okay, let's apply that one. So once we apply that, this is done. Okay. Achha. Now, if I do something, there's something called get support. If I click on get support, you see true, true, false, false. So if you see that one, you'll see there চারটা ফিচার আছে। প্রথম দুটো যেন ট্রু ট্রু বলছে, তারপর সি এন্ড ডি জন্য ফলস বলছে। তার মানে সি এন্ড ডি আর দ্য ওয়ান্স দ্যাট আই উড হ্যাভ টু drop because these are the 0 variance features. Is it clear, Nakina? Yes? Right?
Yes, sir.
Okay. So now, of course, you can look at this one and can say, okay, I'm going to drop feature C and D. But you can you can make it, you can automate this one. How do you do that? Look at this way we're doing. What are the features? All the features, data.columns. Data is the data frame. .columns, all the features are there. Data.columns, I'm going to bracket a var underscore thresh dot get support day. That will give me the ones that are true. So the features that I should select. So all the features we have are A, B, C, and D, but the features that we should select are A and B, not C and D. So now we can do it like this way. I can write a simple code over here and look at the code. Selected columns equals to what? The data.columns var thresh dot get support. So these A and B are the selected columns. Then we run a loop for calls in data.columns. Data.columns means A, B, C, and D. So আমরা loop চালাবো and দেখব if the calls, let's say first one is call A, if it is not in selected columns, is it not in selected columns? Is A in this one? Selected columns আছে?
Yes, sir.
Yes, sir.
It is there, so this is not going to be true. Then I'm going to look for the next one, which is B. B কি আছে?
Yes, sir.
Yeah, so we're gonna look for the next one. C কি আছে?
No, sir.
Now, so if the call is not in the selected column, so it is not there, so what I'm going to do, I'm going to drop that particular column. So I'm going to drop C in place equals to true, so C would be dropped. আবার run for the for column D. Column D কি আমার selected column আছে?
No,
D কি আমার selected column আছে? নাই. Then I should also drop the column number D. Okay, that's what I should do. So once I have done that, I have dropped this. So if I now see my data frame, you'll see that the data frame will have A and B in it, and C and D have been dropped because they are 0 variance features. ঠিক আছে? Okay, these are the features, constant features. That means they have 0 variance. ঠিক আছে নাকি না? Is it clear নাকি না? Do we understand that? Sir, I wanted to start with second algorithm, but today it has been really crap over here. Internet is going down all the time. Again, it's going to go down now. So I'm going to close it right now over here. Is that okay? Like now? Yeah?
Yes, sir.
I'll see you guys on Friday. Friday we have an exam in the morning, and then we are going to also meet on the Friday at 4 p.m. Right? Like now? Yeah?
Yes, sir.
Okay, thank you very much.